Welcome to another session. In this session, we'll be looking at trigonometry. So the question that we're given here, it's in this case, it's question 5. So we have 5.1 on question 5. So we are told that in this diagram, we have a point P, which have coordinates of K and 24. And this is a point in the second quadrant such that OP will equal to 25 units, right? So this is what we're given. And we're also told that N is the point on the positive x-axis and PON is what is theta, right? So the first thing they ask us without using the calculator, right? So we have to determine the value of theta, right? So um, without using the calculator, we need to calculate the size of theta. So in this case, they ask us to determine the value for k for the first one here. So the value for k, if we can check, k is a point in this line here, right, which is OP. So k is a point here at P. So first of all, what we need to do when we're given a point here, in this case, we're given a point here at the second quadrant, what we need to do, we need to draw a line that extend to the x-axis. Always you need to draw a line that extend to the x-axis so that you write your x and y values. Okay, so in this case, what is our x value? Our x value, we can see it's k. Okay, and then what will be our y value? We can see here is 24, right? And then now we can determine our k value. How can we determine our k value? Okay, so this, right, it's a right angle triangle. So this one is a right angle triangle. So if this is a right angle triangle, we know we need to use what? The theorem of Pythagoras to find this x side, right? Or the adjacent side. So how can we find k? We use the theorem of Pythagoras. From theorem of Pythagoras, we know that the hypotenuse, which is r squared and x squared plus y squared, right? So the hypotenuse squared is equals to x squared plus y squared. Okay, so in this case, we do have our hypotenuse, which is 25. So this will be what? Will be 25 squared. And then do we have our x? No, we don't. So it's our k. So we write our k here, k squared plus y. Do we have y? Yes, it's 24. So it will be 24 squared. Okay, so all we need here to do here is to solve the value for k. So let's make k squared the subject of the formula. So we'll have 25 minus 24. Remember to square this because we're squaring this. Okay, so we can use our calculator. Okay, so 25 square minus 24 square is 49, right? So we get 49. Okay, so k squared will equal to 49. Okay, and then the value for k, we just find the square root here and also the square root here. So k will equal to plus or minus what? 7. So the square root of 49 is plus or minus 7. So what will, which sign of k do we have to take here? Are we taking a positive or are we taking a negative? We have to look here, which quadrant are we in here, right? Is the second quadrant. If you can see here, we're on the second quadrant. So on the second quadrant, the value for k, in this case, k is our x, is our adjacent. The value for k is what? The value for k is what? Is negative. So we have to select negative 7, right? So the value for k is negative 7. Okay. Then moving forward to 5.1.2. So 5.1.2, they ask us to determine tan theta, right? So we know that tan theta is what? Is opposite over adjacent. Okay. And then what is our y value? The y value we know is 24, right? And then what is our x value? The one that we just calculated here for our adjacent, which is k. So it's what? Is it will be negative 7. So negative 7. So 24 divided by negative 7 is our value for tan theta. Okay. And then moving forward, we need to determine 5.1.3. We need to determine sine theta, alpha. In this case, sine alpha, not theta, sine alpha. So, but what we need to do here, the key that we need to remember here, we are told that theta plus alpha is equals to 360. So we don't have alpha, so we must express alpha in terms of theta. So alpha in terms of theta will equal to what? 360 minus what? Minus theta, because you can see here theta plus alpha equals to 360. So it means that alpha will equals to 360 minus theta. So we can put it here, we can substitute it here on our sine alpha. So instead of writing alpha here, so it will be what? It will be 360 degrees minus theta, right? Okay. And then for this, you need to remember 360 minus theta. Which quadrant is this? Okay, if you can check from your cast, you can quickly draw a cast diagram here. Okay, so it means here, this is your fourth quadrant. Only cos is positive. Here, all the functions are positive, and then here, only sine is positive, and then here, only tan is positive. So 360 minus alpha, right? It falls on the the fourth quadrant. This is the fourth quadrant here. It falls here on the fourth quadrant. So it means that we know that cos on the fourth quadrant is what? Is positive. Therefore, uh, sine on the fourth quadrant, it has to be negative. In other words, we'll have negative sine theta. So sine 360 minus theta will equal to negative sine theta. Okay. So we already um, determined. If we look on this function here, we know our theta here. So from here, we need to determine our sine theta. So our sine theta, we know its opposite, which is 24. This 24 divided by the hypotenuse. Okay. So our sine theta is what? Is opposite, which is 24 divided by the hypotenuse, which is 25. So you should not forget the sign, because we know that the sign is what is on the fourth quadrant. Okay. So moving forward, 5.1.4. Okay. We need to determine cos, okay, 5, let's put it here, 5.1.4. We need to determine cos square theta minus sine square alpha, right? So for cos square theta, we can look here on our diagram here. Cos, we know that cos is what is adjacent over the hypotenuse, right? Adjacent over the hypotenuse. And then sine, we know that sine is what is opposite over hypotenuse. Okay, so need to be careful. We already determined our negative our sine alpha. So we, from question 1.3, we already determined our sine alpha. So all we need to do here is to determine our cos square theta here. So what will be our cos square theta? We know our opposite is our adjacent is what is k, which is 7. So negative 7 divided by r, which is what? Which is 25. Okay, remember our k is negative 7. It's very important to take note. And then we need to minus this with sine square alpha. We already determined our sine alpha. So if we can go back, our sine alpha, this is our sine alpha. Here we expressed it in terms of theta. We got it to be what? Negative 24 divided by 25. So it's our sine alpha, negative 24 divided by 25. Okay, so it's negative 24 divided by 25. So we should not forget to square this. Okay, now we find our final answer. So we can use our calculator here. So the first one will be negative 7 divided by 25. We need to square this, then minus negative 24 divided by 25, and we need to square this. Okay, so this will be our final answer. So our final answer will be, so in this case, we are not supposed to use the calculator as it was stated. So without using the calculator, what we know, these are perfect squares, right? So you can verify with your calculator, but you should not use the calculator. So if you square this, you square 7, you get what? 49. And if you square 25, you can confirm, can just confirm. So you need to show all your calculations. So you get 625. 625. And then here minus 24. You need to square 24. So you just need to show everything. 24. You can square this. You get 576, 576, and then this one becomes 625. Okay, so you know that if you have 625 here, so you can just minus 49 and 576. Okay, so you can do it like this. So 49 minus 576. Okay, is negative 527. Negative 527 divided by 625. So you can leave it like this. So it will show you this final answer. This is your final answer. You can leave it like this. You showed all the steps and you should get the full marks. Okay. Okay, so moving forward. Okay, let me move this down. Okay, so for the next one, we have a sketch below that shows two graphs of f and g. So we're also given this is very important, the interval is very important. Okay, so negative 60 up until 120. So that's the interval that we are working with. Okay, so the first question here, they ask us to write down the coordinates of the maximum turning point of G in the given interval. So we need to determine the coordinates of the maximum turning point of G. What is G? So you need to determine what is G. G is this graph here. So the maximum has to be somewhere here. This is the maximum turning point of this graph on the given interval. So for 6.1, so the coordinates will be what? Will be 30 degrees is to 2, right? So it's 30 degrees is to 2. Okay, so those are our coordinates. Okay, so for 6.2, they ask us to determine the values for x where f is strictly increasing. So in the given interval, so we can see our f here. This is our f. Okay, can mark it with a different color. This is our f. So where is our f increasing? We can see here f is increasing, and it reaches the maximum point here, and then it begins to decrease. So where is our x decreasing? I mean increasing. We can see, as we stated, it's increasing between here, which is negative 60, and 0 here. So we can see that our x is increasing between negative 60 x and 0 here. So between negative 60 and 0, our function of f is increasing. Okay, and then 6.3. Okay, 6.3, they ask us to determine the values for q and b. Okay, so if we can start with q. So q is on our f graph. Okay, so we can see our f graph. So what q means, it's q is the vertical, um it's a vertical shift, so it can either go up or go down. So we know from our original cos function, we know that the original cos graph cuts here at what? At 1, and then goes right like this. But we know that it cuts here at 1, so the maximum here has to be 1, right? So that's what we know. So here we can see it has gone down, right? It has gone down to a half. So this is half here. You can see it's half. So it has been shifted down uh, half units, right? It has been shifted down half units. So it means that since it has been shifted down, our value for q will be negative half, because this graph is being shifted down negative half units. Okay, and then our our B, right? Our B is from our G graph. So our G graph, okay, is this one here. So remember, B represent what? It multiplies what? The X. So it represent the period, right? So we have to look how is this period behaving. So if you can check here from 0 to 120, it's one period, right? We can see the period is what? Is 120. Remember, when you calculate the period, right? uh, Always the period is 360 divided by that, the period equals to 120. In this case, the period is 120. So we want to see what are we dividing with to get uh, 120, right? So we need to uh, confirm what we need to divide with here. How do we confirm that? We can cross multiply, right? Okay. So when we cross multiply, we have 120 p equals to 360. Okay. So this, when we divide, you'll get what? You'll get 3. So it means the period it has to be divided by what? Has to be divided by 3. So it means what? It means that our value for B, our value for B will be 3. So we need to divide by 360 by 3 to get the period of 120. Okay? So that's our value for B. So moving forward to 6.4. So 6.4, we need to use the graph to determine the values for x, okay, for which 2 cos x sine 3x minus sine 3x is greater than or equal to 0, right? So from this here, what we are given 2 cos x sine 3x minus sine 3x greater or equal to 0, right? So we can see we have a common factor here, which is sine 3x. So we can take out the common factor of sine 3x. And we can also take out these two, right? Because when we take out sine 3x, if it's if we also take out 2, it becomes what? It becomes this function. It becomes 2 sine 3x. So now that we determine the value for b, it becomes what? 2 sine 3x. So it's this equation here. Okay, so let's take out 2 sine 3x. Okay, and then here we'll be left with what? We'll be left with um we'll be left, okay, let me put it here. We'll be left with cos x minus half. Okay, so we'll be left with cos x minus half. So cos x minus half is this one, is this function here. Cos x, remember our value for q is minus half. So it becomes this function here. So it's like we're having what? It's like we're having g of x times f of x. So greater or equal to what? To 0, right? So we need to check where the product of these two functions will be greater or equal to 0. So when we look here, this one is positive, this one is negative, right? So positive and negative will never give us a positive. Remember, we want greater or equal to 0. But when we start here at 0 here, we can see this one becomes what? 0, and this one becomes positive half. So they are all positive from here, from 0 to 60. They are all positive. And also here from 60 to 120, they are all negative. We know that negative and negative is what is positive. So you can see from here 0 to 120, this function is what is positive, right? So the product of these two functions is positive. So that's what we needed to know. The product of these two functions here, right, from 0 to 120 is positive, right? So what does this mean? It means from 0, remember one our x values, from 0 to what, to 120, this is where our function will be greater than 0, or greater or equal to 0. Okay, we have come to the end of today's session. Please don't forget to like and subscribe, and I'll see you on the next video. Thank you.